So this question number 2 is asking you to differentiate this and then find the value of the differential when x equals 1.5. So the first thing to do is to differentiate it. So look at the table of differentials that you got on the exam paper, and we can see that sine becomes cos and the a comes out in front, and cos becomes minus sine with the a coming out. So applying that to this, we've got that dy by dx equals, cos becomes minus sine, so that's minus 2.1, the pi comes out, times the sine of pi x. Minus sine becomes minus cos because sine becomes cos, so minus sine becomes cos. So minus, the pi comes out, cosine pi x. So that's our expression for the differential. It might be worth just looking at it and actually seeing that we could take minus pi outside a bracket. It's not essential to do this, but you know, the more you can demonstrate that you can use algebra and all the rest of it, the more I'll be looking to give you marks. If I were to factorise this, taking minus pi outside the bracket, that would leave 2.1 sine pi x plus cos pi x inside the bracket. Multiplying out the brackets, you can see that minus pi times that gets us back to the first term, and minus pi times this gets us back to that term. So you could factorise it, taking minus pi outside the bracket. We've got to find out the value of this differential when x equals 1.5. So again, we just put x is equal to 1.5 into here and work out the answer. What's the thing I've got to be aware of when I do this? Nope. As soon as I see sine, cosine functions appearing, what do I think? Is it degrees or radians? Answer? Radians. Because there's a pi there, okay? It's not a degrees, it's in radians. So check your calculators in radians. I've mentioned this already last time, you know, you're switching from radians to degrees and so on. Somebody's going to make that mistake. Okay? So plug the values in, see what you get for the differential. So if you put the numbers in, making sure you're in radians, dy by dx turns out to be 6.6, or you could leave it as 21 pi over 10, or 2.1 pi. Any of those answers would do.